All right, we're ready for solutions, so let's cover some basics. What is a solution? Well, it's a homogeneous mixture, which means we use AQ to identify it because that means dissolved in water. Saturated solutions are at dynamic equilibrium. So we'll learn more about exactly what that means later, but remember, equilibrium means the rate of the forward reaction and the rate of the reverse reaction are equal. So when we're talking about a solution, we mean the thing is dissolving and then recrystallizing or solidifying. So the rate of it dissolving would be equal to the rate of it solidifying, okay? Or recrystallizing. So what are the parts of a solution? We have solute and solvent. Ugh, could they make the words any closer together? Seriously, solution, solute, solvent? Come on. All right, so what are the parts? Okay, so I remember it like this. Solute, you dissolve it. Solvent does the dissolving. So you put the solute in the solvent, and the solvent dissolves it up. And together, that makes the solution. Like in math, the solution is the answer. So you put the solute in the solvent dissolves it, and you get, voila, the solution. Okay, so the solute dissolves in the solvent. So again, you take the solute, put it in the solvent dissolves it, and you get, voila, the solution. Okay, solute plus solvent equals solution. Went through it a few times. It should make sense. Okay, again, are you ready? Solute is the thing you put into the solvent. You stir it up, the solvent does the dissolving, and you get, voila, the solution. Now, when water is the solvent, that is when we call it an aqueous solution. That should make sense. Dissolved in water, aqueous, okay? Which sample of matter is classified as a solution? Yeah, this one. Which statement describes KCl with an AQ after it? Well, do you remember what solutions are? Are they homogeneous or heterogeneous? So do you remember that? If you do, you should know that heterogeneous is wrong. So now I am down to a 50-50. So I have to remember if KCl is the solute or KCl is the solvent. Remember, the solute is what you put in. Stirred up, the solvent does the dissolving to give you the solution. So it would be the solute. Okay, so now I have a reaction. I'm going to skip this up here and just go down here. Maybe I'll need it, but usually I don't. Compare the rate of dissolving KNO3 with the rate of recrystallization of KNO3 for the saturated solution. Well, when it's a saturated solution, the rates are what? What? Do you remember? Equal. Because a saturated solution is at equilibrium. So the rates are equal. The rate of dissolving equals the rate of recrystallization at equilibrium. Okay, my question, it's in red. Identify the solute. So again, you take the solute, put it into the solvent, stir it up, the solvent dissolves it, you get the solution. So it says 200 grams of water at a temperature of 60 degrees Celsius, prepare a saturated solution of potassium chloride. So what's the solute? What's the thing I'm dissolving? Well, I've got water and I've got KCl. Solute KCl. Not every solution is the same. So some terms you may have heard before, dilute versus concentrated. So dilute barely has any of the solute in it, and concentrated has a lot. So how could I increase the concentration? Well, one of two major ways. First, add more solute. So if I'm making Kool-Aid and I mix it up and I'm like, oh, that is not sweet enough, add more Kool-Aid. Okay. If I make it and it's too sweet, if I add more Kool-Aid, that won't fix it, right? So I could use less solvent, okay? So in the case of it's already made and I want it to be less concentrated, I would add more water. But if I want it to be super sweet and it says add 2 cups of water, I'll add 1 cup of water. Ridiculously sweet. So if I start with less water, it will be more concentrated. If I add more solute, it will be more concentrated. So adding more solute to increase concentration. So I keep the volume the same, right? So I have 100 milliliters of water and 100 milliliters of water. Just in one of them, I add more of the solute. So the one that has more solute is more concentrated. Or I could use less solvent. So I put the same amount, so I put 10 grams of sodium chloride in each one, but in one I only use about, say 60 milliliters, and the other one I use 300, okay? The one that has less liquid will be more concentrated. Okay, so 2 major ways to change the concentration. I either add more solute or use less volume of the solvent. Okay, how can we change the rate of dissolving? What do I mean? Well, let me show you an example. I have a glass of water right here. What else do I have? Some salt. Okay, so what I'm going to do is I'm going to open up this salt. Okay, and we are going to pour salt into this glass of water. Okay, now how can I change this rate of dissolving? Because I have a lot of salt hanging out at the bottom. So how? What can I do? I think you probably already know some things. So how could I change this rate of dissolving? What could I do? Do you have some ideas? Well, let's see if you're right. First, agitation. Stir it, mix it, shake it. So I take my glass and I take a spoon and I agitate it, okay, to get more to dissolve. I stir it up. That's one way. You probably thought of that one, didn't you? So shaking or stirring. So this one right here, which looks like something weird is happening, it has a little magnet at the bottom, a magnetic stir that is stirring it. So it's like on autopilot. You may have thought of this one, temperature, so heat it up. So I just took this water straight from the tap, but how about if I put it in the microwave first? Or if I heated the water on the stove first? Use warm water. It will dissolve faster. So in most cases, increasing the temperature increases the rate of dissolving. You could see that illustrated here with putting drops of food coloring in. In hot water, the food coloring starts to dissolve a lot faster than it does in cold water. Also, if I wanted to make this orange juice, I would thaw it first, right? Trying to get it to dissolve when it's frozen, oh my goodness, takes so long. So warm it up, right? I thought. So salt or sugar, whatever, it's going to dissolve faster in hot water. Did you think of this one? Increasing surface area increases the rate of dissolving. So if I want the sugar to dissolve faster, I'm going to use sugar particles instead of a sugar cube or a chunk of sugar, okay? So smaller compounds dissolve faster because they have more surface area. So we talked about this in our last unit. So looking at this, right? Which one is going to dissolve the fastest? Would it be this one, or this one, or this one? Which one is going to dissolve the fastest? If you thought this one, you were right. Largest surface area, it will dissolve the fastest. Okay, so what is solubility? It means the ability to be dissolved. But not every substance dissolves. You probably know this, oil and water, right? Okay, let's look at this question. A whole bunch of reading. I'm going to skip it. It says, what change other than temperature would affect the rate of dissolving? Okay. So it doesn't say increase the rate of dissolving. It often does. So I'm going to frame it as increasing the rate of dissolving, but in reality, I just have to change it. So I could change the surface area. If I wanted to increase it, I'd have to say increase surface area. But if I want to change it, I could just say surface area. I could shake it or stir it, right? That's what we talked about, changing the rate of dissolving. Temperature, surface area, agitation, right? Shaking or stirring. We're going to discuss solubility in greater detail, but as a little hint, solubility is affected by things like the type of substance, temperature, pressure, and so on. There you have it, basics to solutions. I hope you learned something new today.